So this paper was supposed to be taken in June 2021, but was affected by COVID, so was taken as extra as unseen paper. Otherwise, it was supposed to be taken in June 2021. For P3, let's move to question number 1. Question 1 is the curve has the equation. This is the equation of the curve given, and x is from 0 to pi. 0 is not included, but pi is included. The curve has a stationary point at P. Now, you should know what is the meaning of the stationary points. Stationary point are turning point, and immediately call how to find the stationary point. For finding the stationary point, we find the first derivative and put the first derivative equal to 0. In part A, we have to show using calculus that x coordinate of P is solution of the equation. In other words, you have been asked to find the x coordinate of the stationary point. Now, how do we find the x coordinate of the stationary point? This is the given curve. Okay, let me write the given curve. Y is equal to x square cos of 1 over 2x. That is a given equation, and we have to find the x coordinate of the stationary point. We have to prove that this is equal to this. We must have to make this result, that the x coordinate is this one. So let's take the derivative of that one, because for finding the stationary point, you should find the first derivative and then put the first derivative equal to 0. Now for finding the derivative, look at this one. Two functions are multiplying, so we will use the product rule. This will be our first function, this will be second function. So let's differentiate the derivative of y, because it is depending on x. So the derivative will be dy over dx. And now what it will be first function, we just write as it is, into derivative of the second function. Remember this rule. If we have the two function, first into second, so we will say first function into the derivative of the second function. Now this is the second function, so the derivative of cosine is negative. It's negative cosine, negative sine, so it will be minus sine of 1 over 2x. And then angle derivative we also have to multiply to complete the derivative. So derivative of 1 over 2x is 1 over 2. That will also be multiplied. Then plus second function then will be as it is. The derivative of first function we will. Now the derivative of the first function for x square is 2x. And that one. So from here I will have dy over dx equals, now I can write it in the simplest form. It will become minus 1 over 2x square sine of 1 over 2x plus 2x cos of 1 over 2x. Now as we have to find the stationary point, x coordinate of the stationary point, so I will put this derivative equal to 0. So you should put dy over dx equal to 0. So I will have now minus 1 over 2 x square sine of 1 over 2x plus 2x cos 1 over 2x equal to 0. So what I will do, I will shift it to the other side. It will become 2x cos of 1 over 2x equals to 1 over 2 x square sine of 1 over 2x. Now if you look at the result that we want to make, it has tangent in that one. So to make the tangent, we know very well, tangent is sine over cosine. So that is why what I will do, I will take this cos to the other side and will shift this one to this side. So it will become actually 2x over 1 over 2x square, and equals to the other side will be sine 1 over 2x over cos 1 over 2x. So this 2 will be multiplied with this one. It will become 4x over x square equals to, that will become tangent 1 over 2x. Now this x will cancel with this x, so I will have here, and take tangent to the other side. It will become tangent inverse 4 over x equals to 1 over 2x, and shift 2 to the other side, so it will become 2 tangent inverse 4 over x is equal to x. And this is what was asked to prove, that x should be 2 arc tangent. Arc means tangent inverse. So this result was asked to prove, that we prove here. That's the end of part A. Now part B is saying, using the iteration formula, this is iteration formula given here. Let me write here x n plus 1 is equal to 2 tangent inverse 4 over xn. And x1 is given equal to 2. So what we have to do, we need to find the values of x2 and x6, giving your answer to 3 decimal places. In each case, your answer should be given to 3 decimal places. Now that's simple. If you look at this one, x1 is given and you want to find x2. Now in this one, how we can make x2? If I will put n is equal to 1, 1 plus 1 will become 2. It means on the other side also put 1. So it will be 2 tangent inverse 4 over, now x1. x1 we have already. So x2 will be 2 tangent inverse 4 over 2. Now here one more thing, look at the question. In the beginning, if you see, the domain is given in the radian. So your calculator must be in the radian mode to do this calculation. Now take your calculator, make sure it is in the radian mode. It's already in the radian mode. If it is not, you should convert it into the radian mode. So you convert into the radian mode. Now take this value, 2 tangent inverse 4 over 2. Okay, that will become 2.2142. I will say that is 2.2142. So, and we have to write to 3 decimal places. So at least write to 4 and then round to 3. So by rounding to 3, it will become this 2.214. Now next I have to find, so I will say x2 is approximately 2.214 to 3 decimal places. Now next I have to find x6. I need to find x6 and it is just 3 marks. Okay. So what you should do for x6, basically what I will do here, I can find for x6 actually I should have the value of x5. So to have the value of x5, I can, one way is first I will put here, then I will find x3, x4, and then I can go for x5. But instead of that, once you found the value with the calculator, then for x6, what you should do, if you want to find x6 from this one, here in the calculator, in this place of 2, for example, in place of 2, what you should do, just write the answer of the previous part that was here, and then what you should do, press equal. You will get the next value x3. Okay, then again put equal, you will get x4. again equal x5, again equal, you will get your x6. So then you can write the final value of x6. That will be 2.155, and then you can round it to 1551, and then round it to 3 decimal places, 2.155. That will be your x6. So that will be simple. Or alternatively, find x3, x4, x5, and then get the value of x6. That's our question number 1 here.